So now, let's move to the next axiom, which is the axiom of monotonicity, or the fifth axiom. So let me define first what does monotonic means. The word monotonic means always moving in the same direction. So in the case of preference relation, always going up. A monotonic preferences means that the consumer always prefers more of a good. It has a condition, this monotonic preferences. Preferences are monotonic if there are no bad goods. Why? When we talk about monotonicity, which we say the consumer prefers more of a goods, but it does not work for the case of bad goods, because for bad goods we do not prefer more of that bad goods than less. For example, if we think about pollution, which is a bad good, we want to have at least as much, a small amount of pollution. We are trying to reduce the amount of pollution as much as we can. So in this case, we do not prefer more of pollution than less of pollution. So it does not work for the case of like bad goods. So we have two kinds of monotonicity, which is weak monotonicity and strict monotonicity. A preference relation on X is weakly monotonic. If this Y has at least as much of every good X. The bundle of Y has at least as much of every good in bundle of X. Then bundle of Y is weakly preferred to X. It means Y is at least as good as X. So, in case of weak monotonicity, more of one good is always equivalent or better than less of that goods. And we have the next one, which is a strict monotonicity. A preference relation on consumption set of X is strictly monotonic. If Y is at least as much as X and Y is not equal to X. Or another way we can say that Y has more of at least one good than X. Y, we can combine this two together. We can say that Y has more of at least one good than X. Then Y is strictly preferred to X. So this axiom demonstrates that more of one good is always preferred to less of that good. More of one good is always preferred to less of that good. And now is the time to discuss about the two last axioms of choices, which axiom 6 bar and 6, which is convexity axioms. So let me, before discussing about the convexity axioms, provide you three other necessary concepts which are necessary in order to know the concepts of convexity, which are indifference set, upper contour set, and lower contour set. So let's define these three concepts, and then we can move to define the concepts of convexity and strict convexity. So what is indifference set? Indifference set is a set of all bundles that are indifferent to a given X, which is this X, and our consumptions such that Y, which is, we have another set, this set is at least as, this set is indifferent to X. So this black bold line, which is the set of Y and R2 plus, where Y is indifferent to X, is indifference set. So this black bold line is indifference set. And then we have upper contour set. Upper contour set is a set of all bundles that are at least as good as X, where X is in our consumption set of capital X, where Y is at least as good as X. this shaded area above the black bold line is upper contour set, which is a set of y in R2 plus where y is at least as good as x. Means this area, this set, the shaded area above this black bold line are at least as good as x. They are weakly preferred to this point of x. So it's called upper contour set. And then we have lower contour set, which is a set of all bundles that x is at least as good as that set. Where we have this set of x and x capital, which is consumption set, where x is at least as good as y. So now the shaded area below, this shaded area, below the black bold line is the lower contour set. There is a set of y in R2 plus where x is at least as good as y. So in this case we have like two goods. That's why we are assuming R2 plus, which is non-negative of consumption of x1 and x2. So this is lower contour set. So now let me define you the concepts of convexity and strict convexity, which is the two axioms here. So axiom 6 bar, which is convexity, a preference relation is convex. A preference relation on consumption set is convex if for every x in consumption set of capital X is upper contour set. So now you know what's upper contour set. Don't need to repeat again. If it's still not clear, just pause the video and go back and see the definition of upper contour set. It's upper contour set where y is in consumption set, where y is at least as good as x, is convex. That means the preference relation is convex if for every x in consumption set, its upper contour set is also convex. So we can define convexity by this statement. For all alpha in a set of 0 to 1, y is at least as good as x, if and z is at least as good as x, implies that alpha multiplied by y plus 1 minus alpha multiplied by z is also at least as good as x. What does it mean? It means that any point between y and z is also at least as good as x. When y is at least as good as x and z is at least as good as x, then any point between y and z is also at least as good as x. To sum up, every linear combination of y and z preferred to x is also preferred to x. Any combination of y and z, or any point between y and z, is also preferred to x. And also we have axiom 6, which is strict convexity. This axiom says for all alpha from 0 to 1, when y is at least as good as x and z is at least as good as x, but when y is not equal to z, implies that alpha multiplied by y plus 1 minus alpha multiplied by z is strictly preferred to x. So this axiom says or demonstrates when y is at least as good as x and z is at least as good as x, but y is not equal to z, then any combination between or any point between y and z is strictly preferred to x. So this is the axiom of convexity. So let's show these axioms graphically to be clear as much as possible. So here is two graphs. What do you think? Before I clear for you, just pause the video and tell me which one is convex and which one is non-convex, and just write down in the comment section below. But by the way, the panel A is a convex preference relation, or is a convex set, but the panel B is a non-convex. Why? In panel A, when y is at least as good as x and z is at least as good as x, and a point in between like this point, which is the combination of alpha y plus 1 minus alpha z, is also at least as good as x. Why? This one is also at least as good as x based on the other axioms that we say is more is better than least. So then this is the combination, the point of alpha y plus 1 minus alpha z has a higher amount of x1 and x2. Then when it has a higher amount of x1 and x2, then it's preferred than x, this point. So this is convex. But how about this one, the panel B? Panel B is non-convex because although z is at least as good as x, y is at least as good as x, but any point between them, for example, the combination of alpha y plus 1 minus alpha z is not at least as good as x. But rather x is preferred to this point. Because in this case, x has more of x1 and x2 than the combination of alpha y plus 1 minus alpha z. So in this case, although y and z is at least as good as x or preferred to x, but the combination or any point between them cannot be preferred to x, then it's non-convex. So now, graphically it's clear what is convex and what is non-convex set, or what is convex graph or non-convex graph. So now, let's distinguish between the convexity and strict convexity, or the convex graph and strict convex graph. So this panel A is convex and panel B is strictly convex. Again, before I tell you about why this is convex, why this is strictly convex, please write down your answer in the comment section below and tell me why A is convex and B is strictly convex. Just pause the video. So, by the way, let me tell you that panel A is convex and panel B is strictly convex. Why is that? Because in the panel A, you can see in this area, this graph is almost linear. Although generally, overall, it's convex to the origin of this plane, but this area is not strictly convex. It's almost similar to linear line, which we have the point of y, x, and z. But this set, or this graph, the panel B is strictly convex. Because as you see, it's clear that it's strictly convex to the origin of this plane. And it can satisfy the definition of a strict convexity, which is when z is at least as good as x, y is at least as good as x, then any point in between, which is the combination of alpha y plus 1 minus alpha z, is strictly preferred to x. Why? Because this point has more of good x1 and at the same time more of good x2 than x. If we keep the axiom of local enunciation and also the axiom of monotonicity, then this point is strictly preferred to this point. It means the combination of alpha y plus 1 minus alpha z is strictly preferred to x. That's why this is strict convex. So now, another most important question that we need to answer, why do we need decimal axioms for the preference relation? Why? Why do we need this much axioms? The reason is, we need these axioms in order to work well on consumer theory, to make a building block of consumer theory. Each of these axioms help us to develop our consumer theory. How? Let's see here. So, the three first axioms, which is completeness, transitivity, and reflexivity, which is called the rational axioms, or the axiom of rationality. So if a person satisfies these three axioms, we can call it that consumer is a rational consumer. In completeness, when we interpret that, any two options can be compared or ranked. You can rank one option over another option. And transitivity says that consumer choices are logically consistent, and reflexivity says that a bundle is always indifferent to itself. Then if we satisfy these three axioms, in terms of utility function, it's necessary condition for having utility function that represent this preference relation. So in order to have utility function, we have to satisfy these three axioms. So now, why do we need the axiom of monotonicity and local enunciations? So these two axioms basically demonstrate that a consumer can always do a little better by having at least more of one goods. Then if we satisfy monotonicity and local enunciation, then utility function is increasing or at least non-decreasing. And also indifference contour set or downward sloping. Why indifference contour set or downward sloping? Because when we move along the indifference contour set, if we want to have more of one goods, we need to reduce the amount of another goods. We need to reduce the amount of another goods. So, and also in case of convexity and strict convexity, these two axioms demonstrate for us that average are preferred to extreme. So it means instead of having one good too much than another one, it's better to have the average, to have the combination of good goods, rather than having one goods too much and least of another goods. So in terms of utility function, so when we satisfy this convexity and strict convexity, in case of convexity, utility function is quasi-concave. And when we satisfy the strict convexity, our utility function is strictly quasi-concave. And indifference contour set or convex to the origin in case of convexity, and is strictly convex to the origin in case of strict convexity. And finally, we need the axiom of continuity, because this axiom will help us to have a continuous utility function. So if we interpret this axiom, it says small changes in bundles have a small effect on consumer well-being. A small effect on consumer well-being. And when we satisfy these axioms, then our utility function is continuous. And in this case, our indifference contour set are also continuous. There's no jump, there's no break. There's no gap in indifference contour set. So that's why we need these actions. We need completeness, we need transitivity, we need reflexivity, we need monotonicity and enunciations. We need convexity and strict convexity, and we need continuity in order to have a well-defined consumer preference relation or a well-defined consumer utility function, which can help us in order to maximize our utility. And the next videos we will cover the concepts of utility and utility function, and also how we can represent preference relation by utility function. And in other words, we will cover the representation theorem. I hope you enjoyed this video and you learned whatever you are interested in consumer theory, especially about the axiom of choices. So let's see you in the next video when we are talking about utility function and representation theorem. Up to the next time, see you guys. Hope you have a great time. And if you enjoyed this video, please subscribe to Econ Minds YouTube channel and also hit the like button and share this video with your colleagues and fellow students in order to grow together and have an enjoyable class of microeconomics theory. Hope you have a great time. Let's have fun.